Go is an ancient board game that originated in China sometime between 1046 BCE and 771 BCE. It is played on a 19 by 19 board with two players, one playing white stones and the other playing black stones. The goal of the game is to completely surround the opposite stones. Compared to chess, which has an average of 10 to the 123rd possible moves, Go has an average of 10 to the 362 possible moves. While defeating the world's top chess players was a major milestone for AI, it was done with what is called a brute force method. In this form of AI, every possible combination and outcome is inspected before moves are made. With the exponentially increased complexity of Go, the brute force method was not feasible for an AI system that could contend with the world's best Go players. AlphaGo was developed by a UK company named DeepMind, founded in 2010 by Demis Hassabis, Shane Legg, and Mustafa Suleyman, and acquired by Google in 2014. It is the first AI system to beat professional Go players. Professional Go players are ranked by a Dan level between 1 and 9, with 1 being the most junior and 9 being the most senior ranked players. Both Fan Hui, the European champion and a 2 Dan player, and Lee Sedol, a 9th Dan player, lost in 5-game matches to AlphaGo. While news of this milestone was spectacular, the accomplishment is not backed by any new technological breakthroughs, but rather a combination of neural networks, machine learning, and software engineering. Machine learning grew out of expert systems and pattern recognition software in the 80s and 90s in an attempt to allow computers to learn for itself rather than have people provide hard and fast rules to interpret every possible data combination. In recent times, machine learning has been used for everything from understanding financial markets to analyzing genome data.
The way that AlphaGo is set up is not necessarily groundbreaking technology. It is made up of computer parts just like many other computers. It is basically standard hardware: 48 CPUs, central processing units, and 8 GPUs, graphical processing units. These are set up to render 3D graphics for the gaming purposes for certain mathematical operations. Neural networks, which is the heart of the program, is a distinct descendant of neuronal circuits in biological brains. In other words, it can make decisions like a human brain. The system uses a quote-unquote value network to decide how effective a move will be to win. It also uses a quote-unquote policy network, which is in a way generates possible moves, which is then judged by the value network that then decides on the move itself. It started with a 13-layer policy neural network, which was given in a series of 160,000 games from a database, learning how professionals would play the game. The machine essentially taught itself how to play the game and predict other players' moves, much like we do when learning a new thing, a quote-unquote trial and error. In a final stage, the program is able to estimate how likely a single move will lead to a win. The system teaches itself by playing the game with itself, thus helping it play the game better. This is called relentlessly self-play. Essentially, we are looking at a machine that can play a game repeatedly in its quote-unquote head that in turn will make it a better player.
By now, you should have a firm understanding on the history of AlphaGo, how it operates, and what it has accomplished. This section will discuss what is next for the AlphaGo team. With Move 37, AlphaGo made history according to commentators and experts. The machine made a beautiful move and went on to beat Lee Sedol in the second match of 5. As you learned, AlphaGo went on to win 4-1. The next step might be another game. Cue up the popular MMORPG StarCraft as the next challenge. According to New Science magazine, in Go, there might be about 300 possible moves at any time. In StarCraft, a strategy video game with hundreds of pieces, there might be 10 to the 300th. You can't even examine all possible moves in the current state, let alone all possible future move sequences, says Stuart Russell at the University of California, Berkeley. In this setting, the AlphaGo AI would have to consider its actions and goals on a higher level, then work out a plan to get there. requiring reasoning methods applicable to a wider range of real problems. Moving past the recreational world of gaming, the neural networks behind the success of AlphaGo might be used in medicine. Intelligence activities involved in medical decision making are much simpler than that in Go Match. It is possible artificial intelligence can replace a human brain to make medical decisions since there are rules governing them. The ultimate challenge has to be the Turing test. Developed in 1950 by Alan Turing, the test requires that a human being should be unable to distinguish the machine from another human being by using the replies to questions put to both. Will the AlphaGo AI and the team behind the machine be able to accomplish this? Well, that's their move, and passing that test will be a win for the ages.